This is a video where we're going to go over the code used for the hula hoop project in ECE 341 and 2. This is based upon some code, C code provided by Alan Burleson, as well as some work done by myself, Don. It uses the WS2812 chip for lighting an LED hula hoop. This is written in pure C. We use the AVR GCC for compilation in the code that's provided. So a lot of this is C nomenclature. If you're unfamiliar with the C language, some of this might not make as much sense to you as it could. So it's highly recommended you do a refresher on that if you truly want to understand the pieces along the way. We're going to start at the top and work our way down. AVR/IO.H is an include that you utilize when you're doing an AVR chip. This is supplied with AVR GCC and allows you to compile for a variety of different processors, and essentially makes the system aware of the various registers that are inside of each chip. We've included util_delay.h. This gives us the option for delay millisecond and delay microsecond. And we've included a WS2811.h file, which gives us the actual code for running the WS2812s in our case. The 2811 and the 2812 are very similar. The 2812 is a upgrade where they combine the LED with the logic chip, rather than the 2811, which is just a logic chip and you had to have an additional LED attached to it. Underneath that, we have a set of defines which allow us to reconfigure the clock speed of the device. We're using a Teensy 2.0 hardware board, which runs a ATmega32U4 processor on it. And this allows us to, if we choose to, set the speed of that device to be slower or faster using those pound defines. However, we've decided that we're going to run at 16 megahertz. That's the FCPU. This is a pound define required by a lot of things within the AVR libc. So basically, a lot of that is boilerplate and should be included. We've also defined a few variables like a pause length in milliseconds, a delay length in milliseconds, and a length of bytes. And then we have some functions that were used. So we're defining a function here that actually allows us to access the WS2811.h file. We have a set of functions we've set up. We'll just skip these for a moment. We'll go right to the actual program itself here in the main. Runs pretty basic. First thing we do is we make sure that our CPU is set to 16 megahertz. Then we want to make sure that the output we're going to use for driving the WS2812s is set as an output. And then we're going to want to set the state of that to be a 0 to begin with, so that we know we're at a known good spot. From there, we're going to go ahead and we're going to create an array of RGB types, RGBT, that we're calling RGB because why be inventive, of length, which in this case we defined as 87 pixels in length. Okay. We're going to set the hoop color. So by default, this function allows us to set the entire hoop to a single color. And we can see that from this function here, where essentially it goes through and it recurses through the entire array, setting each one of the array elements to the RGB values that you're passing in. So that's what we can see here. We're essentially clearing at 0, 0, 0, making sure that everything's off to begin with. Then we're going to set the pixel color of a single pixel to the RGB values. And we can see those here. Set pixel color. So we have two different types, one that takes in a type pixel and one that takes in the RGB values independently. So this is the actual one that we're using. And so we're setting the, not the 0th, but the first, so one forward element in the array to be not red, not green, all blue. So it'll be a blue LED. And we're updating that array. From there, we have an update function. This update function actually updates the hula hoop, the lights, with the data that's currently held in the array RGB. So we chose to do this because we want to be able to make the lights on the hula hoop turn off and on at a known rate, and so that we could do a little bit of animation, or we could do some specifics to that. So what we wanted to do is set it up so that the refreshing of the LEDs was independent of the preparing what the LEDs would display, so that we could do math or other calculations we might want to do in the background and then only update at the required rate. In this case, we haven't fully implemented it, but that's why we split these two pieces into parts. Then we have a short delay. Okay, this section, if you're used to Arduino, pretty much everything in main here corresponds roughly to the setup portion of an Arduino code. The while one, this corresponds roughly to the loop function within an Arduino code. And within the loop, all we're going to do is we're going to update to display, we're going to delay a little bit, and then we're going to run a rotate. This just rotates the current array of LEDs one click so that the blue LED, as it's running forever, will appear to rotate around the center of the object. So that's the overview of the basic code. One thing that I find really interesting is if we actually go look at the code that's supplied originally for this WS2811, is how they actually implement it. So the WS2811 is a very time-dependent protocol, so things have to be exact. In order to do this with a microcontroller, the developer of this library actually went and worked with assembly so they could get a cycle-by-cycle control over the I/O pin that's being indexed. So this level of control allows for very precise timing within the realm of what the clock crystal is for the chip, but you cannot interrupt it during this process. If you try to interrupt during this process, you're going to lose the data along the way. And so you'll notice that this code actually disables interrupts when it comes in. And to make sure that, well, you can read it through yourself, to make sure that it doesn't get interrupted during the middle of the process. They go through a set of these no-ops here are actually used for setting the delay of the timings. And this allows them to actually get a very precise timing on the output. This is another reason why it's important that we do the update separate from setting up the array of colors, because we don't want to have to be updating frequently. We want to have to only update every so often, so we have plenty of time to do other things in the code. So that's the quick walkthrough of this code. If you have any questions, please feel free to contact me.